Hello my dear students, welcome you all to a Mathswell YouTube channel, a virtual platform for mathematics. So today we are going to discuss and going to solve some important examples from a very important topic from the grades 9 and 10. Okay, so here the name of the topic is surface area and the volumes, right? So students, we are going to find the surface area and the volumes of some solids, right? The first solid we are going to see, it is a cube and a cuboid, right? So what is the difference between cube and cuboid? The difference between cube and cuboid is, for a cube each surface is a square, right? Means the edges of the cube, they are equal in length, right? So length, breadth and height, they are all equal. Okay, and if we denote it by A, we denote the length, breadth and height of this cube is equal to A. Okay, now let's see cuboid. So what is the cuboid here? Cuboid will be again a solid, a three-dimensional solid, so in which each surface of this solid is in rectangular form. Means what? So the opposite edges, they are equal, so opposite sides of the rectangle, they are equal. So we can say here, if we consider this as a length, this one as a breadth and this one as a height, so the cuboid will have the length, breadth and height, right? So this is the difference between the cube and cuboid. So today we are going to discuss about the total surface area, the lateral surface area of cube and cuboid, and some example on the same. Okay, so let's see what is the total surface area of a cube. We denote in short form this total surface area as TSA, that is total surface area of a cube. So how to get the total surface area, how we can find, and how we can remind this formula, how to get or how to find the total surface area of a cube. As we know students, the cube has 6 surfaces, is it? If I denote the surfaces of this by numbers, I will just choose some different color here. Okay, so these are the surfaces, the front and back, then the left and the right, and then the top and bottom. So in this way we have the 6 surfaces of this cube and cuboid. So for this, as we know, each surface is a square, and we know what is the formula to find the area of a square. So this total surface area is nothing but the sum of areas of all the surfaces of a cube. Means what? It is the sum of all the 6 squares, right? And we know if the A is the side of the square, then the area of the square is given by A square. This is the surface area of each surface of this cube, which is equal to A square. And we have such 6 surfaces, hence we can say, or we can write, the total surface area of a cube is equal to 6 times A square, that is 6A square, right? So in this way you can have the formula to find the total surface area of a cube is equal to 6A square, where A is the edge of a cube, right? So this is the first formula here we have. After that we come to the surface area, total surface area of a cuboid. So as we know, the total surface area of a cuboid, each surface of a cuboid is in rectangular form, and we know how to find the area of the rectangle. So what is the area of a rectangle? The area of rectangle, if length and breadth is the length and breadth are L and B of a rectangle, then the area of that surface will be equal to here L into B. Now here, as we have the surfaces having the length, breadth and height. Here it is a cuboid, it is a solid figure having 3 dimensions, the length, breadth and height, L, B and H, right? So here the front and the back, that is the surface 1, surface 2 are having the dimensions, the length and height, right? Then the surfaces 3 and 4, they are having the dimensions as breadth and height, whereas the surface bottom and the top, they are having the dimensions as the length and breadth. So in this way we can add those surfaces, the areas of these surfaces having different dimensions, right? So in this way we can add them, since each surface, the top bottom, they are having the same area, the left and right surfaces are having the same area, and the front and back surfaces, they are of same area. So in this way we can write the twice length into h, it is the length area of the surface having the dimensions length and height, that is the front and back, right? Then twice b into h, b and h, that is breadth and height, that these are the dimensions for the left and right surfaces, right? And then the 2lb is nothing but, that is L into B is the area of the bottom and the top surfaces of this cuboid, right? So in this way we add up all these areas to get the total surface area of a cuboid. So in this way, student, we have the formula to find the total surface area of a cuboid as twice LB plus BH plus HL. So that is the second formula for this chapter. So total surface area of a cuboid. Student, we can also find the lateral surfaces, lateral surface area for this cubes and cuboid. What do you mean by lateral surface area? The lateral surface area will be only the sum of the areas of the lateral surfaces. So here, which are the lateral surfaces? The surface number 1, 2 and 3, 4. They are the lateral surfaces. So whenever you are asked to find the lateral surface area, or if you require the lateral surface area, then we need to add the areas of these 4 surfaces only, right? So here for this cuboid, the lateral surface area will be the sum of the squares of 4 spaces. That is the sum of the 4 squares. Each is having its dimension as a, side is equal to a, so it will be obviously 4a square. So here I can write one more point, the total after total surface area I can write the lateral surface area of a cube, which will be equal to 4a square only, right? So instead of total surface area, if you want only the lateral surface area, then we can use the formula as 4a square only, right? After that, we can also find the lateral surface area of a cuboid. What will be the lateral surface area of the cuboid? Again, it is the sum of the areas of the surfaces number 1, 2 and 3, 4 again, right? So what are the area of the surfaces 1, 2? They are having the dimensions L and H, so it will be twice LH. Similarly, areas of the surfaces 3 and 4, they are having the dimensions B and H, so it will be twice BH. So you can say it is twice LH plus BH. So H is common there. So I can write its lateral surface area of such cuboid will be twice H is common and L plus B. So this will be the lateral surface area of a cuboid. So whenever you require the lateral surface area, we can use this formula. So we can keep this formula in mind. In some example, you may ask to find the surface area or surface area of the boxes which are open at top. So in that case, we can just subtract the area of this one part, that is the top of this, that is 6th surface. That area could not be added there. So in that case, what will be the total surface area of such type of boxes? It will be, so instead of taking twice LB, L into B, we take only 1 times L plus B. So in that case, for open box, so I can write here the total surface area of an open box. So in that case, what will be the total surface area in that case? It will be LB taken only once and remaining areas we can take twice. That is BH plus HL. So this will be the total surface area of a open cuboidal box, you can say here. More precisely, it is a cuboidal box having length, breadth and height. And in the case if it is a square box, in that case what will happen? What will be the total surface area of an open cube box, right? It is cubical box, we can say. So in this case, we have only 5 surfaces. Each surface is having the area a square. So in that case it is easy to write that the total surface area of an open cubic box or cubical box will be equal to 5a square. We have only 5 surfaces for such open boxes, right? So in this way we can find the surface areas of such boxes, either the lateral surface or the open boxes. Hope everyone understood all this formulae, right students? So with the help of these 4 formulae, we are able to solve the example from the book. Okay, so let's see the example from the books. Let's see the examples. The first example we have taken. So student, here we have the first example. Let us see. A plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is to be open at the top. Okay, ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box and the cost of sheet for it if a sheet measuring 1 meter square costs rupees 20. Right? So first, in such type of example, students, we need to read the sum very carefully and try to write what is given and what we need to find. Okay, so here you are given that the area of sheet required for making a box which is open at the top. Here first we are trying to write the formula how to get the area of the sheet required for making the box, the open box we can say, which is open at top. So in this case, as we have discussed earlier, the formula will be LB plus twice BH plus twice HL, or taken twice 2 common, it will become this one, LB plus twice BH plus HL, right? Okay, so here you are given, what you are given, just you can note here, given that the length of the box is 1.5 meter, the breadth is 1.25 meter and the height will be equal to 65 centimeter, or it can be converted in the meter. The same unit should be there, so that we are converting this 65 centimeter to a meter. So here we need to divide it by 100 to convert it in meters. So we have the height is equal to 0.65 centimeter. Okay, so with the help of this formula and the given information, we can find the area of the required sheet, which is given by, as we have noted already, the formula is LB plus twice BH plus HL, right? So it is 1.5 into 1.25 plus twice 1.25 into 0.65 and 0.65 into 1.5. So simplifying this and doing the calculations carefully, finally we have the total surface area as equal to 7.8 meters square. So you need to do the calculations very carefully, students, right? Okay, fine. So after that we have the cost of sheet. As students, we know the rate of the sheet is given for 1 meter square and we have calculated the total surface area of the sheet. So the formula will become the rate of sheet into the total surface area of the sheet. So here we need to multiply, the rate of sheet is rupees 20 per meter square and the total surface area is 7.8 meters square. So just take the multiplication of these two, it will give us 156.0. But what is 156? It is cost of sheet. So that we can write the cost of sheet is equal to 156 rupees to make that open plastic box. Understood, students? Yes. So this sum is very simple. So similar type of example will be there for the on this part of this topic, right? So now let's see the next example. The next example is like this. I will just show you what is the sum. So students, here we have the next sum. The next sum is the floor of a rectangular hall has a perimeter 250 meters, right? If the cost of painting of the floor 4 walls, here we need to find the cost of painting the 4 walls of the room, that the hall, at the rate rupees 10 per meter square is, it is given here, the cost of painting is given at the rate of rupees 10 per meter square is equal to 15,000 rupees, right? The question is find the height of the hall, and you are given the hint that the area of the four walls is nothing but the lateral surface area of a cuboid, right? So as just we have in the earlier part of this video that we have seen that we can find the lateral surface area. We know the lateral surface area, right, of a cube and cuboid. Here this hall will be in the form of cuboid, right? So let's use the formula for lateral surface area of a cuboid, right? So what is given, just you can note, you are given that the perimeter of a floor, the perimeter of a floor is given, how much it is, the perimeter of the floor is given 250 meters, right? And the cost of painting for 4 walls, it is given as rupees 15,000 at the rate. What is the rate of the painting? The rate of painting given is rupees 10 per meter square, right? So students, what we have the formula to find the lateral surface area of a cuboid? That is nothing but the area of the four walls of the hall, right? So it is nothing but the 2 times BH plus HL or 2 times 2H times L plus B, right? So this is the formula to find the lateral surface area of a hall. So let's just substitute the values of the hall, that is the length, breadth and height. So students, before finding this lateral surface area, you are given the perimeter of the floor. How you can find the perimeter of a floor? The floor is again in rectangular form having the dimensions length and breadth. So it is given by twice L plus B, and as you are given that perimeter is 250 meters, we are able to find L plus B from this. So how much is L plus B? So L plus B taken kept as it is and taken 2 with the 250, which is divided to 250 and will gives us 125 centimeters, right? Is it in centimeter or meter? I think it is in meter, not centimeter, right? So this will be in meters. Right? So this is in meter. 125. Sorry, it is 112.5, not 125, because this 250 divided by 2, 2 1s are 2, 2 2s are 4, 2 5s are 10. Is it? Is it so? 112. Wait, I need to check. 2 1s are 2, 2 2s are 4, 2 5s are 10. It is 125 only. Okay, it is 125. We'll write here 125. 125 meter, right? So students, L plus B is 125. So substituting in the formula for LSA, that is lateral surface area, it will give us twice H times L plus B. So L plus B is given as 125. We will have it as 125. So multiplying it by 2 will give us 250 H. So it is in terms of H. The lateral surface area is in terms of H. And also you are given the cost of painting, right? It is given 15,000. So which is obtained by taking the multiplication of rate of the painting and the lateral surface area, right? And which will give us the height of the hall. So cost of painting is 15,000. The rate of painting is 10, and the lateral surface area we just obtained is 250 times H. So simplifying it and having the value of H here 15,000 and is divided by 2500, because 10 into 250 will become 2500. It is taken to this side is changed, it is divided to 15,000. So simplifying it, it will give us the value of H is equal to 6 meters. What is here? It is nothing but the height of the hall, right? So hence we can say the height of the hall is equal to 6 meters. So hope everyone understood this example, right? So we'll just see what we are discussed here, how we have solved it. As we are given the perimeter of the floor, so using that perimeter of floor we calculated L plus B. Then using the formula for the lateral surface area, we got it in terms of H, as L plus B is 125 meter. The LSA will come in terms of H, that is 250 H. And then we calculated height with the help of the formula to find the cost of painting, which is nothing but the rate of painting into the lateral surface area, right? So simplifying it, it will give us the height of the hall is equal to 6 meters. So now let's move ahead with one more example and then we'll stop here. So student, here we have one more example. The example is like this: the paint in a certain container is sufficient to paint an area equal to 9.375 meters square. The question is how many bricks of the dimensions. So here the dimensions of the bricks is given as, that is 22.5 centimeter, 10 centimeter and 7.5 centimeter. Means you are given the length, breadth and height of the brick. Okay, so how many such bricks can be painted out of this container? So student, here you are given the total surface area that will be used to paint, right? And the a brick, the dimension of a brick is given, the length, height and breadth is given for a brick. So let's use the given first. So what you are given in this example, students, you are given the total surface area to be painted, which is nothing but 9.375 meters square. Also you are given the length, breadth and height of a brick, which is nothing but 22.5 centimeter, then 10 centimeter, and after that height is 7.5 centimeter. But as the area is given in terms of meter, we can convert them in terms of meters by dividing each of these dimensions by 100. So how much it will give us? It will give us, dividing this 22.5 by 100 will give us 0.225 meters. Then 10 by 100 will give us 0.1, and then 7.5 if it is divided by 100 will give us 0.075 meters, right? So now, as the total surface area to be painted, it is obtained by multiplying the number of bricks by the total surface area of the one brick. So are you able to find the total surface area of a brick? Which is very simple, just by applying the formula of finding the total surface area of a cuboid, that will give us the required area of a brick. So if we denote the N as the total number of bricks to be painted in the paint available in the what is given, it is a container, or some container is there, right? So the total surface area to be painted is equal to N times 2 into LB plus BH plus HL. So it will give us the formula to find the number of bricks to be painted. So it is obtained by taking the ratio of this total surface area to be painted to the total surface area of a brick, right? So we can find the total surface area to be painted is already given. Just here we need to find the total surface area of a brick. So first we will find it, the total surface area of one brick, which is given by this one, that LB plus BH plus HL, right? So using that formula and substituting the values will give us the total surface area of a brick. How much it will be? Just the calculation is very important part here. So this twice, just substituting the values of L, B and H and simplifying, taking the calculations, doing them very carefully, multiplication and so on. So here it will give us the total surface area of a brick, which is given by, or we have after calculation as this much. How much it is? It is 0.9375, this much. This is the total surface area of a brick. Now, as we know the formula to find the number of bricks to be painted, it is given by 9.375, which is nothing but the total surface area to be painted with the help of the paint in the container. It is given already, and is divided by the total surface area of a brick, which is just we have obtained as 0.09375. So student, whenever such decimal numbers are there in the multiplication or in division, or especially in case of division, first we need to convert them in integer form by multiplying and divide by some a number. The number should be in the multiple of 10 only, so that we can remove the decimal places, right? So here we have the maximum number of decimal places. Here the digits after decimals are 1, 2, 3, 4, 5, and in numerator we have only 3. So we need to multiply by that multiple of 10 which has the 5 zeros after it. In that number we must have the 5 digits. So how much it will be? It will be obviously 1 lakh. So we need to multiply and divide by 1 lakh to remove the decimal there. Okay, so it will gives us, multiplying numerator by 1 lakh will gives us this much, that is 9,37,500, and in denominator if we multiply by 10,000 this 1 lakh, it will gives us directly a number 9375, that is 9,375. So taking this division, it's very simple division. Both the numbers are having 9375. Just cancelling this, it will gives us 100. And what is that 100? 100 is nothing but the number of bricks to be painted with the help of or the paint in the container. Right students? So in this way we can find the total surface area, and then we have found the number of bricks to be painted. Hope everyone understood this, right? So student, these are some typical examples. So such type of example may ask in the exam, so you are supposed to do the practice of such type of examples, right? So in the next video we will solve more examples of the same kind. So till then you can just practice these examples, okay, and try more examples from the book if possible, right? So with this note, today here only we will stop. In the next video we will see more examples on this part with the help and we will continue with the next part of this topic also, right? So keep learning students. We'll see in the next video. Thank you.